Hello everyone, let's talk about another easy problem on Leetcode today. Convert sorted array to binary search tree, Leetcode 108. In this, we are given an integer array nums where elements are sorted in ascending order and we have to convert it into the height balanced binary search tree. And what height balanced binary search tree means is that it is a binary search tree such that the difference between the left and the right subtree is at maximum 1 and then the left subtree is balanced and also the right subtree is balanced. So for example, in this tree, we can see that the difference between the heights of left and right child of node -3 is 1, right? Because there is no right child. Similarly, for 9 also, the height difference between the left and right subtree is 1 again. And for node 0, the height difference is 0, right? Because there is no difference between the heights of the left and right child. So what this problem says is that we have to convert this sorted array. So in this case, we can see that -10, -3, 0, 5, and 9 results in one tree like this, or we can also get a tree like this one as well. Both of them are balanced, so we have to produce either of those trees. The reason the problem is asking for height balanced binary search tree is because if suppose we insert the nums from example 1, so we take -10 and then we insert it into the binary search tree and then we add -3. It's greater than -10, so it will be the right child. Then we insert 0, which is greater than -3, so it will again be the right child of -3. Then 5. So if we continue doing this, we will actually get a skewed binary tree or like a linked list where the left pointer will be null always and nodes will always have a right child. And that is not the answer. But what we want is a balanced binary search tree. So let's see how we can get it. Let's look at this example. So we can see that the array is 0, 1, 2, 3, 4, 5, 6, 7. So let's somehow the values are also same as index, but we will be talking in terms of index. So these are the index. So we can see that low or the leftmost pointer is 0 and high or the rightmost pointer is at 7. So we find the middle element, or we will initiate the tree node with value 3. And now we have to search for the left and right children of this tree. So we recurse to the left sub-array and right sub-array. So that's how the recursion will work. Then we can see that for this array, 1 is in the middle. So that will become the left child of 3. Similarly, here we can see that array with 4, 5, 6, 7 is actually a even array. So we can either take 5 in the middle or 6, but let's go with our algorithm. So it will be like low plus high by 2. So low is at 4, high is at 7. So middle will be 7 plus 4 by 2, which will be 5. So 5 will become right child of 3. Similarly, now we will fill in the left and right children of 1. So we can see that 0 exists on the left of 1. So 0 will become the left child of 1. Similarly, remaining subarray on the right is 2. So 2 will become right child of 1. Similarly, for node element 5, there is only one element on the left, which is 4. So that will become the left child of 5. And now on the right side, there are two elements remaining 6 and 7. So 6 will be the middle. So 5's right child will be 6. And then on 6, there is no element on the left side. So it will be null. And on the right side, there is 7. So 7 will become the right child. And that is how the whole algorithm will work. And the reason is, if you remember in binary search tree, when we do the in-order traversal, it is always in the increasing order. So basically, we are trying to decrypt this in-order traversal for us and trying to create a binary search tree based on it. I hope this was clear. Now let's jump into the code part. So first thing we will do is we will create a tree node. That will be the root, right? And we will pass it to the helper function. So we will pass nums to it, 0 to it, and high to it. So high will be nums.length -1, and we will just return this root value. Now let's write this helper function. So we know that if low is more than mid, that means we have covered whole array. And in this case, we will just return null. But otherwise, we will just say int mid is equal to high plus low by 2. Then we will just create the tree node from the middle element. Now we will recurse on the left and right side of the tree as well as the array. So we will just do root.left is equal to helper nums low and mid -1. And then similarly for the right side, we will do nums mid +1 to the high, right? That's the right side of the array. And we will just return the root. Yeah, hopefully this will do it. Let's run this code. Cool. Let's submit the code. Awesome. In terms of time complexity, it will be O of n, where n is the length of the array because we are processing each element in the array only once. And in terms of space complexity, it will be O of log n or O of n because we are creating a balanced binary search tree. We are going down the stack height of the binary search tree. So it will be O of log n, but we can also say O of n. So that's it. I hope this video was helpful to you. If it was, please like and subscribe. Have a nice time.